everyone, Jeff here. Welcome back to Imagination Tech. So today I wanted to show you this quad, which is a 7-inch long-range cruiser that I built, and this is officially the largest drone in my fleet. Now, I'm going to be taking you on the step-by-step build process on how I built this, as well as some videos at the end of this thing in flight. Now, if you're subscribed to this channel, you might have seen my unboxing video of some MEPS parts that I received back in November, and I made that video in December. And we are going to be using some of those parts here in this build. Mepsking sent me these motors, the FC and the ESC, for free. I did not have to purchase it, but they did not pay me to make this video. No one had pre-approved what I'm going to say. In fact, they sent me these parts back in November. So normally if you have a contract, they would require you to make a video in 2 weeks, and it's already January, so almost end of January, so we're closing into 3 months already. And if you stay tuned till the end, you might watch something that MEPS might not be 100% happy about. All right, stay tuned. So this is the frame that we're going to be using for our 7-inch build. You can notice the really long arms with a relatively small fuselage. And the way these things go with a lot of 7-inch frames is that they just take the fuselage or the main body from their 5-inch build or their 5-inch frame design, and they just slap on longer arms. And it's also how this is with this frame. It has a typical 5-inch mini quad fuselage or main body, but it has these arms that can handle a 7-inch props. So I've already pre-assembled this. We're just going to take off the top plate, and not going to be discussing much about this frame because you might be using a different frame, and it doesn't really matter. It's most of these frames are pretty similar anyway. It's just they would just differ in how they are assembled, but you can take any 7-inch frame that you want and still follow along with this build. Alright, now we've taken off the top plate. You'll notice that here on the center, as with most frames for 5-inch or for 6-inch or for 7-inch, your typical frame would have you know, screws or holes at least that are configured something like this. These are 30 by 30, or rather 30.5 by 30.5 hole patterns. So there's a 30.5 millimeters distance between all of these screws. There's also a smaller hole pattern in case you want to put a smaller flight controller or stack here. These are for a 20 by 20 stack. And there's also a 20 by 20 stack here at the back. So in case you want to mount your maybe a VTX that has a 20 by 20 mount, or you can even put a mini 20 by 20 stack here at the back. So this is the stack that we are going to be putting on the 7-inch build. This is the MEPS Space SZ 60 amp 4-in-1 ESC, and this is the MEPS F7 HD flight controller. Both are from Mepsking, and I discussed this briefly in my unboxing video of these products. So do check that out. I'll link to that in the description, as well as put a card up here in the corner. So right now the first thing we have to do is we'll take off this wire harness first. And then the first thing we need to do is to put the gummies here on the stack. So this flight controller and ESC came with all of these accessories. You have your wire harnesses, you have your gummies and a capacitor. Even the pigtail came with the ESC, as is pretty much standard with electronics for FPV these days. And there's also this wire harness which connects your FC to your flight controller to your ESC. And I just soldered on this pigtail quickly. It's not a very good job, but I just wanted to test it out in Betaflight, make sure that everything is working. So I'll just remove this pigtail quickly and we'll put it back later on. So included in the package is 5 of each of these gummies. You have these taller ones and these short ones. Now, if you notice in our frame, it's already elevated by these lock nuts. So we're going to go with the shorter ones, but ultimately that's going to be a decision that I will leave up to you. But we don't need the taller ones because that'll put too much space in between. So just to illustrate, you can see that's where our board is going to go. And if we use the short one, it's going to be much lower. And you have to consider we also have to have our flight controller up on top. So if you've ever built a drone before, you'd probably be already familiar with how to install these gummies. It's never a pleasurable thing to do, but it is doable, especially once you get the hang of it. So that's how I do it. I just squeeze it and then just push and pull. A lot of electronics do come already with these gummies pre-installed, and that's very much appreciated. So with the SpeedyBee, it already comes with a set of these gummies pre-installed, but again, they probably left that out with this one because you have a choice of using a short or tall gummy. We'll just finish up the rest of this as well as on the flight controller. So I've got the small gummies installed on the ESC, and I've got the taller gummies here on the flight controller. I got them all from the Ziploc bag of the ESC because they are identical anyway. They are the exact same gummies, but I just didn't want to open that up yet. I mean, it's already open, but I wanted to use the ones I got from the ESC first. So the layout of the wiring connector is indicated here on the sales screen underneath the ESC. So we'll just follow along. Use this as a guide. So you have your negative, positive motors 1, 2, 3, and 4. I guess that's your current meter, and then ESC telemetry up on the last. And you will notice that on our flight controller, it is exactly the same order. It's minus, plus, 1, 2, 3, 4 current meter, and R4, I believe it says. It just means that your R4 is going to be used for ESC telemetry. So we just plug that in, and that's basically it. Now we just need to install this here, and then install our stack up on top. Now, if you're using a different flight controller or ESC combination, there's plenty of wires here. You have a harness here where the connector is already pre-installed on one side, but you have your extra connectors here, so you can just switch these wires around to suit you whatever ESC or flight controller you're going to be connecting to. So first things first, we're going to be pre-tinning all of these pads that we are going to be using, starting with these ESCs as well as the power pad. So I mentioned this in my unboxing, and you can see that there are quite a number of pads on our flight controller. So like I mentioned in my previous unboxing video, you have a lot of pads here in your flight controller. You have UART2 over here, you have UART4, you have UART3, and UART5. Now we are going to be putting a GPS unit on this because this is going to be for long range. So we're probably going to put it here on UART5 with 5 volts and ground right beside it. And if you do plan on using something with a compass like a BN880 or a BE880, you also have SCL here and SDA. So either you can put it here on either UART5 or UART3. But we're going to be using UART5 because UART3 we're going to be using for our crossfire. Or if you have ELRS, you can hook that up here as well. And we are also going to be putting our beeper up here on top. You have your buzz negative, which is the signal wire going to your buzzer. You have your 5 volts, which is the red wire, and ground for the black wire. Now, since this is a digital flight controller, it has this connector for your air unit or your Vista, or in our case, we're going to be putting a walk snail Avatar VTX on this, and this connector has 10 volts ground, UART1, and there's also 2 other pins, ground and R2, but we are only concerned about the first 4 pins, 10 volts and ground to power our Avatar VTX, and UART1. Included with the flight controller is this 6-pin harness. So again, we are just interested in the first 4 wires, and we're going to be probably removing these 2 wires, and then we're going to connect these wires and to our Avatar VTX. Now that we've soldered all our pads, we are just going to put this aside for a bit. And here I have my Avatar HD VTX, and if you have a Cadex Vista, then you would put it here as well. The hole pattern on the frame is 16 by 16, so we are not going to be able to screw this on because this is a 20 by 20 hole pattern. But what we are going to do is we can probably just zip tie that. I've already installed the TPU and the antennas as well, and it took a bit of wiggling, but I was finally able to push all of the slack inside. We'll just tighten that up with zip ties, and we're also going to put our GPS here. Now, unlike with most analog systems where the camera is wired directly to the flight controller and the VTX is also wired to the flight controller, with a digital system you would most likely have your camera wire going directly to your VTX, and that's why we're going to put this wire underneath our VTX, and that's why we removed it. So we are just going to put this back on and put our flight controller back on there as well. All right, so we've pretty much all of the major components are right here. We're also going to be adding our GPS unit over here, and we're gonna figure out the wiring in a little bit. And for our crossfire receiver, we are going to be mounting it here because this is for long range. I want the antenna to be mounted vertically, and so we're going to have to remove the antenna of the crossfire receiver when we're not flying, but when it's flying it's going to be a vertical position, and that'll give us a better range with this drone. Next, we'll just tin the ends of these wires. Now we can solder in each of the wires. Take note, for this GPS unit, the wire beside ground is the one that goes to RX, and the other wire goes to TX. And we give this wire a twist. Okay, now we just slide this in here, connect our GPS unit. Now we do the same thing for our crossfire receiver. So Walksnail VTXs come with their own connector that plugs into the VTX, but the other end are just wires which you would need to solder onto something on the flight controller. Unfortunately, the one downside to this MEPS flight controller is that there are no pads for the digital input connector. So that would be fine if you just need a spare UART, but you also need at least 6 volts to power your Walksnail VTX and also your Cadex Vista. And the 10 volt connector here, 10 volt pad, well, there is no 10 volt pad, so it's just the connector or nothing else. So luckily the flight controller came with this wire, and originally this end that you see here, this was connected to this connector, and I just used a box cutter to lift off the lock tabs in the plastic to remove these connectors. And now I can just plug these right in to this connector after I remove all of these wires first. So you just need to lift off these tabs, and once that's lifted, you can pull the wire right out. We're just going to be doing that for all 4 wires, but we are going to need to keep these connector safe and sound and in good condition. Now that I removed the wires from this connector, I just need to put the wires back in the correct order. So we'll start with the positive first. So now we have a wire harness that connects to our flight controller as well as our Walksnail VTX. So we connect it here, and the other one plugs into the flight controller, but let's twist this first. Right. So we're just trying to fit everything first. We're not going to keep this all permanent because we still need to solder in our pigtail later as well as our motors, but I think right now we have most of our parts laid out in our frame, and we'll probably want to zip tie these antennas as well so that they don't keep moving. This ESC came with this 470 microfarad capacitor, and goes up to 35 volts. I'm not sure if that's visible. So yeah, I would have preferred something like 1,000 microfarads for this size ESC, but it's not really a problem, and we don't have a lot of space inside. So what I like to do is to wrap the legs of my capacitor with some heat shrink, just leaving the last part exposed. And now just need to slot these legs into the holes that are specific for the capacitor. And you have to take note that this capacitor has a polarity, so you take note which side you insert through the negative pad. So I'm just going to solder on this side to secure these the legs of the capacitor. Now that we've soldered on our pigtail, I'm just twisting these wires, this wire harness for the between the ESC and the FC. So I'm just going to plug it in there. And for our crossfire receiver, I'm also going to just slide it in here and snap it into place. So it's probably just going to bend a little bit, and then I'll put some sticky tape underneath here, or maybe something like this. And our VTX wire harness also goes in here. Finally, we can install the motors on the arms, and we would just need to place this here and then use the included screws that came with the motors on the underside. Now, a lot of motor manufacturers these days already have thread locker pre-applied onto their screws, and you would see that because there was a color blue on that. But these screws from MEPS looks like it came straight from the factory, and so we are going to be applying our own thread locker. So considering they're a premium motor, I would have preferred that it already comes, you know, with some thread locker pre-applied, but you only need a small bit, and you would just thread this in to your motor and get your screwdriver or hex driver. And we're not going to tighten it just yet. We want to install all of the screws first. So once you have all 4 screws in, you just need to, you know, tighten them in a diagonal pattern, just as you would with your car lugs. And now we just need to do the same for all of our arms. While their screws didn't have thread locker pre-applied to it, they are really nice looking screws. They're looks like really good quality screws. And if this is going to be your first build or your second build, there's a lot of things to say about Mepsking, but stingy is not one of them. They provided a lot of spares, which is more than I can say for a lot of different motor manufacturers who just give you, maybe 1 screw spare. But this one, with these motors, you get 2 complete set of screws for free. It's a minor thing, but it's something I appreciate. So these motors are really meant for a large multicopter, and you can see these are really, really long wires. I think these are more than almost a foot. Maybe these are 10-inch wires. These are definitely more than 6 inches. So what I'd like to do is to first tidy these wires up before we cut them. So we're just going to wrap it with this cloth tape around the arms. So this is the super simple, easiest, most basic way of doing your motor wires. But if you've watched some of my recent builds, I've been using these MR30 connectors so that I can easily swap out motors. And these are 5-inch motors, so I have a lot of them, a lot of spares. And I lost one motor. It was a quick and easy replacement. Just pulled, I just put this motor on. This was actually from another quad, and I replaced the whole motor set of that. But for this one, this is a 7-inch build. These are the only 2806 motors that I have, and I'm not planning on having that kind of hot swappability on this. And so another way of doing this would be race wire, or in my case, I have a lot of these wire mesh lying around, so I might as well use it. It makes it a little bit, a little bit neater. So it really depends on your personal preference on what kind of, or how you want to tidy up your arms. Now that all of my motor wires are nice and neat and also trimmed down, I am just going to add some solder onto the ends of these motor wires. And once you've tinned the ends of your leads, you just need to solder it down onto the ESC. The order of the wires doesn't matter as long as you solder them side by side. So as a comparison, this is a SpeedyBee F405 version 3 flight controller, and this is cost just around $60. So it's a pretty, this is one of my favorite flight controllers because it's cheap, and it also has all of these pads. Now you also have this connector for your ESC, just like the one on MEPS one, but they also have breakout pads underneath that connector. So again, just like the MEPS flight controller. But what I like about this one is that this was actually built for analog, in that it has an OSD chip. So if you put an analog VTX here with an analog camera, you can use it with Betaflight. You can configure it with Betaflight and display an OSD in your display. But if you want to use it for digital, you can do that as well. There are plenty of pads here at the bottom. There's a breakout pad for 9 volts somewhere here. I think this is the 9-volt pad, which you can power your Walksnail Avatar VTX or your DJI CADX Vista or whatever the HD VTX you have through this 9-volt pad. So that's one thing that the MEPS flight controller is lacking, is that you need to rely on their HD connector for plugging in your HD VTX, but it doesn't have breakout pads for powering your VTX. So that's one limitation of that flight controller. Right, so we're basically done. We've soldered all of our motor wires. I've already mounted the crossfire on top of the flight controller with some double-sided tape. The stack screws aren't, as long as I'd want them to be. These are the size of the screws, and these are flathead screws. And unfortunately, I don't have any longer screws, and these are the ones that came with the frame. These are spare ones that I bought, but these are also the same size at 18 millimeters. So you'd probably want something like 20 or 22, maybe even 24 millimeter screws for this, and it has to be flathead to fit in this frame. So yeah, since I didn't have any screw left for a nut, I just used a zip tie for the flight controller, and I also sandwiched my receiver over there, so at least nothing is shaking when it's flying. I also secured my Walksnail Avatar VTX with some zip ties as well. So there are 3 zip ties more than I'd prefer, but I've built much worse quads that that flew great, and this is part of of know-how of how to build quads, is to also figure out solutions to to some of these problems. Our top plate, I also printed this out. This is a GoPro mount. I probably will not be putting a GoPro on this, especially for long-range flights, but you never know. So this is a really nice mount that I found on Thingiverse. It has this lock here at the bottom, and you can also screw it on top. You will also screw it on top. So this vertical crossfire antenna mount, this vertical Immortal T mount, I had to also cut some of the plastic and melt some of the plastic so that the camera plate would fit, because this was a little bit too thick. So yeah, again, you just have to find solutions to some of the problems you might encounter during the build. So we're basically done. We're just going to cover this up, put our battery, we're going to stick our battery pad here so that our battery doesn't slip off during flight. One last thing is we are going to be using these Gemfan long range 70-35 bi-blade props, and these are really long, and this is what we're going to be putting here. And you can see that there's actually still a lot of space on these arms. You could probably put an 8-inch prop here and it would still fit. All right, so now we connect our quad to Betaflight, and the default firmware here is 4.3.1. You can upgrade your firmware to 4.4, and yeah, maybe we can do that. We chose to auto detect the board, and it says it's a T-Motor F7 target with a 4.4.3. Okay, so we're just gonna click load firmware online. It's gonna load the firmware file. And once that's done, just click on Flash Firmware. Right, so once it's done flashing firmware, just click on Connect and then click on Apply Custom Defaults. There are a few warnings here. It says there's no motor output protocol set and accelerometer is not calibrated. We'll do that in a little bit. So here we have our accelerometer and we want your quad to be on a flat surface. Let me just fix this. Okay, so now it's on a flat surface. Just click on Calibrate Accelerometer and that's it. And then I usually turn on in-flight calibration, but we'll do that later on. If you remember, our UART1 is where we have our digital VTX connected, so we have to turn on MSP for that. And then for peripherals, we will choose MSP plus DisplayPort. Now, if this was an analog VTX, you would not be turning on MSP and you would just be selecting probably Smart Audio or IRC Tramp, depending on your VTX. So we set it up for MSP plus DisplayPort. Crossfire is connected to UART3, so we'll turn on serial RX there. And our GPS is connected to UART5, so we'll just look for GPS. We're done here, and we'll just click Save and Reboot. Okay, so next up is the Configuration tab. We'll keep this at default. We'll just put MEPS, for now, MEPS 7. Right, for our MEPS 7-inch build. Okay, D-shot beacon, RX lost, RX set, and then for arming angle, we want it to set it to 180 so that even if it crashes upside down, we'll be able to arm our quad. In-flight accelerometer calibration, yep, I want to have that on. I usually have that on anyway. GPS, we already have a U-Blocks protocol already set, and we'll set this to Autobot use Galileo and set home point once because we don't want to arm somewhere up on the mountain and it'll reset the home point. And here we'll just click on auto detect and we'll just click save and reboot. Next up, we'll go to the presets tab. So here you would be looking for I think walk snail. We'll just need to use this one, OST for FPV, WATF, DJI-03, Avatar HD. Map to DisplayPort, set HD OST, and then use DisplayPort MSP VTX on whichever UART you have your VTX connected to. In our case, it's connected to UART1. We'll just click on pick, and that's it. And then we'll just click save and reboot. On our receiver tab, I'll just turn on telemetry. We're already set for crossfire here, serial via UART. So everything here is just gonna keep it at default. We just turn on telemetry, click on save and reboot. On the motors tab, this is where we would need to plug in our battery. So when you're doing this, you want to make sure that your props are not, you don't have your props on your motors, just to keep things safe. So I plugged it in, no smoke, getting the 4S voltage from my 4S battery that I plugged in. Let's set this to D-shot 600. Okay, so click save and reboot. So my motors are making a sound now because we are on the right protocol. So we click on I understand the risks, and spinning motor 1 should spin this back right motor, and motor 2 would be the front right, 3 is the back left, and 4 is the front right. Okay, so everything is in order, so we don't need to change the motor order. We just need to check the direction. So let's just click I understand the risks. I prefer to do this manually, individually rather. So you just click and hold on 1 and you feel if your if your motors are spinning the right way. By the way, I prefer to do this with a reverse motor direction, so this is how you're going to expect the motors to spin. So let us save and reboot that first, and then go back to motors tab and then click on motor direction. So again, we want to feel if 1 is spinning the expected way like this. So 2 is not spinning like this. It's spinning actually counterclockwise, so we'll just reverse that. So now if you do that and you feel number 2, it's spinning the right way. Do that again for number 3 and it's spinning the right way. 4, we need to reverse, so now it's spinning the right way. Okay, so that is it for this tab. We are all set, and now we just need to set our OSD. So here you already have your HD OSD already set here, and we are just going to, you just need to configure this to however you like. So here I have my default OSD that I always use. It's what I'm used to. You would configure this, really depending on how you would want to set this. I would turn off VTX because I used to use this when I was on analog, and I have 3 OSD profiles, so I normally switch between if I want to show an OSD GPS stats or not. So 2 used to be just the difference was showing the VTX, my VTX channel and power, but not going to use that now because I'm on digital. So we'll just click on save here. For failsafe, this is another thing that we want to set. So this is normally set to auto. The default for pitch, roll, pitch, and yaw is hold, but for throttle, hold means maintain last good value received. So we'll keep it at that. For Betaflight 4.3, this used to be like it brings the throttle down. So for the 1.5 settings, the 1.5 seconds that you lose signal, it drops your quad. But right now it's set to 4.4, so we'll leave it at that. We want our drone to not to land to, but to GPS rescue and to return home. So what I would set here is the minimum distance to home. It's now set to default of 15, but the minimum is actually just supposed to be 20. The rest I'm going to leave at the default. I also want to have a minimum satellites of just 6, or even 5. I'm not going to take off with just 5 satellites anyway. It's just that it gives me a buffer in case while flying and the number of satellites drops to below 8. It's not going to do a sanity check on me. So I'm arming without fix in case I want to take off even if I don't have the minimum satellites yet. And the maximum altitude during that flight will be my altitude mode. So if I lose GPS rescue, it's going to rise up to that maximum altitude. So if you're flying up over a peak, then it's going to record that as the maximum altitude. And if you drop down towards the lower, on the underside of the peak, and you lose signal, then at least it's going to go fly up towards, over that maximum distance. Sanity checks on failsafe only. Yeah, that's good. So let's just click save and reboot. Now finally, you just need to set your modes here. This is where you would set your switches. So just like OSD. Again, this is just for according to personal preference. I always still have angle mode somewhere on a switch just in case. I'll have GPS rescue. I'm not sure which mode yet, but beeper and turtle mode I usually put on a single switch, single aux switch. So I'll put down aux 3. So the middle would be the beeper, and the latter part would be aux would be for turtle mode. So everything is set. GPS rescue would be on aux 4, and then we have aux 5 for setting our OSD profile. Right. So once you've set that to your liking, you just click on save.
So I just did a hover test, and the motors were very, very cool even at stock PIDs, and you need just a little bit of throttle to take off. And one change I did was put the GPS mount on the arms as well. And this way we avoid any of the interference that the digital VTX is very notorious for. It doesn't matter if it's a walk snail or a DJI VTX, it's going to mess up with your GPS. But here I'm getting really good satellites, so I think that this was the right choice instead of mounting it here at the back underneath that antenna and having the wires go over that walk-snail VTX. Another thing I put here was the beeper unit. As you can see here, I just mounted it on a pigtail, which works fine. At least I secured it with some zip ties, and these two combined will make sure that even in the case of a crash somewhere out there, I'll increase at least the chance of recovering my quad. I have a whole video of how to make sure that you get your quad back after flying, so do check that out. Alright, so we're here now at Green Valley. We're just going to give this 7-inch MEPS build a test flight.
So here it is on its maiden flight, and the first thing you'll notice is I took off at around 17% throttle and just cruising at around between 17 to 20%, occasionally blipping it to 22 or 24% throttle. But yeah, you're going to be able to cruise on this thing at really low throttles, which is great for efficiency and great for long range. And that's because it's very light. It's around 472.5 grams, which is just as light as my other quads, other 5-inch quads. Even my Frelon Y6 just weighs around that thing. And this one has the added advantage of having those big beefy motors and those long 7-inch props. So it's going to be really good on your battery, and you can really fly a long time with this thing. Now this thing currently has a 1300 milliamp hour 6S pack on this flight. And you can see I didn't take off at full battery. It took off around 24 volts, and we've flown for just just a minute. And so I'm just going to be flying around this place. I flew a little bit of freestyle, not really aggressively, but I did some split S's, some power loops, stuff like that, just to see the capability of this thing. And this thing is really smooth on these stock PIDs, but it is also capable of doing some a little bit of freestyle tricks, and it can handle it without even a lot of prop wash. At this point, I've already flown for more than 7 minutes, and the battery is down to 21.5 volts. And while I haven't been really crazy doing some crazy freestyle moves with this thing, I also wasn't just merely cruising around or hovering. I was trying to fly, trying to push this thing, really trying to drain the battery is what I was really trying to do here, because it was staying at around 22 volts and now it's just at 21.5 volts. But this is going on for around more than 9.5 minutes before I have had to lay this thing down. So it's really efficient on the battery, especially since it's going to be meant as a long-range cruiser. And again, I didn't even start with the full battery. I took off around at around 24 volts, and right now it's it won't go below 21.5 volts even if I'm trying to really drain this battery. So yeah, this is really efficient in terms of battery. So this is really going to be great for long range, which is what this build was really meant for. It is still capable of doing freestyle if you want to freestyle with a 7-inch, but probably not a good idea. But I mean, you can if you want to, but yeah.
So I was testing the GPS rescue on this, and I accidentally disarmed from 30 meters up in the air as it was doing its return to home, and it actually held up pretty well. It hit the roof there before bouncing off that other green roof on the other side, and then eventually bouncing to the concrete floor. So all things considered, this thing pretty much took a beating without taking much damage and just smiling through it. Okay, so let's put another pack in. I think it was the battery that took much of the beating though. It's a little bent, and I'm not sure if this thing would still hold a charge, but yeah, we'll take this home and see if we can still use this thing.
So unfortunately, that was the last flight I had with this 7-inch long-range cruiser today. When I plugged in the battery, it did not turn on. The ESC turned on. I could hear the motors, but the ESC was not powering on. So I plugged it into Betaflight. It was still functional, So that means the voltage regulator on the flight controller wasn't working. It wasn't providing power to any of the peripherals like the VTX or the GPS and the receiver. Unfortunately, I can't really say that it's the fault of the flight controller because it was a really hard crash. I fell from a high distance. It hit two roofs and the concrete, so that might have been the cause for the damage. Now, if you are handy, you have a good soldering workstation, maybe a reflow station, and some magnifying glass, you might be able to replace the voltage regulator on this. But for me, I'll just have to send this over to Andy, and then for the meantime, probably put a SpeedyB flight controller on this one. I have a spare one lying around. So, but yeah, everything else, the ESC, I tested it on Betaflight. The ESC was working fine. The motors were running fine. We're still spinning. So this is going to be a quick repair for me. I'm just gonna do a quick swap of the flight controller, and this is going to be airborne. Unfortunately, I wasn't able to fly this long range yet, but it flew for 10 minutes on a 6S 1300 milliamp hour pack. So that is quite impressive for something that really was intended for long range. If I could fly that on a 1300 milliamp hour pack, imagine what I could do with a, let's say, a 21700 multi-cell pack with 4000 milliamp hours. So that's going to be our next step, is to try to fly this really long range. That other battery pack should last us maybe 20 minutes, and we can really get some really long range with this thing. Now, even if this is for long range, it was it felt really light on the sticks, but that was a very light battery. So I think it would be just fine with a 6S 21700 pack, even with twice the weight, because I think I was cruising at around 20% throttle, maybe less. I'll have to check the OSD, but you just have to put in a little bit of throttle, and it's going to be airborne. So if you're just going to go for range or going to go for cruising, you don't really need a lot of throttle. And this 21700 is going to give you a lot of range for this thing. So yeah, it really does actually quite floaty actually in the air, probably because of the 7-inch props. Provides lots of thrust, lots of authority in the air. So I was not really expecting a lot, but it's actually flew quite smoothly, even on the stock PIDs. So I'm going to leave you with some more of the DVR footage or from the walk snail, and let you be the judge of how this thing performs. All right. So I'm going to be leaving you with that, and I'm going to get on with the repair so that I can use this for a long range mission tomorrow. If you like this video, make sure you hit that like button, and also make sure that you're subscribed to this channel. All right. And if you enjoyed this video and found it informative, found it useful, maybe considering send me a coffee or a Patreon. The links are down below in the description. All the parts that I used here, the MEPS ones, as well as the TBS receiver or the walk snail, and everything else that I got that is not for Mepsking, is also going to be in the description below, as well as all of the 3D printed parts, so do check that out. So as always, keep building and keep flying. I'm gonna go ahead and repair this thing.